Hello friend, today we will discuss about the laser micro machining process. Earlier we have discussed so many processes of the non-conventional manufacturing, and all the lectures are available on the YouTube channel of the Engineering College Banswara. So you can refer all the lectures available on that YouTube channel. Today we will discuss about the laser micro machining. In last lecture we have discussed about the micro machining process. So laser machining we have already discussed in the initial lecture. This is about the laser micro machining. Now what is a laser micro machining? Laser micro machining: cutting, drilling, welding or other modification in order to achieve small features. Actually, a laser is used in a different purpose. As we can see, it can be used for the cutting of any component. You can also use as a drilling. So you want to create a hole in the material. Even you can use to join the material like weldings. Okay, so main thing is that in laser, first one is the power source and second is the speed. So suppose you have control on the speed and the power source, so you can use same instrument or same technology for the different features. Micro machining implies that parts are made to size of 1 to 999 micron. So you can see this is a difference between the normal machining and the micro machining. In micro machining, we are creating the component, or we are doing the machining of any component which is having a dimension in the micron. However, micro also means very small. In the field of machining, manufacturer of small part are not easy. So you can, as we have discussed, now people are moving towards the nanotechnology. So in nanotechnology, the component are to be manufactured in the micron size or nano size, means size minus 9. So it is very difficult to do the machining of that component by the normal machining process. Laser have been used in various industrial sectors such as the automotive and aerospace industries for many years, performing cutting, welding and materials processing tasks. You can see even nowadays normal machine are having this attachment. Some 3D printers are available also. They are coming with this technology, small machine. So basically what we have a laser source for the cutting, and the rest of things are common, that is the CNC control. So we can change the head of that machine, and that machine can be utilized for the cutting also. So that is also a small operation that can be performed by that machine. More recently, there has been an upsurge in the microengineering application of laser, where the pulse laser in particular have played a major role in the development of the numerous microsystem technology. So you can see, suppose you want to learn more about the laser technology, so you can refer our lecture. That all lecture are available on the YouTube channel. So from that you will get the idea about the laser, the different types of the laser technology, solid gas, how this technology is working and developed. You can see this working principle of the laser beam. Here all the main components have been shown. Like you can see this travel, actually if you observe, that is the travel path from point 1 to point 2. Suppose we are assuming that point 1 is the laser origin point, so that laser it will generate the laser, and ultimately that laser should be reached to the workpiece. So then and then we can use this laser energy for the cutting of any material or different operation. So in that we are using the different lenses. Laser is nothing but it's a laser energy will transfer through the many lenses. You can see here we have energy attenuator, beam homogeneer, then it will transfer to the lenses. Here we have a machine vision system, target illuminator, a precision motion state, a focusing length, and finally on workpiece. So you can refer this onto the earlier lecture about the laser beam machining process. So ultimately what we are doing, we are focusing a laser on the workpiece and it will get melted and evaporated. A laser machine consists of a laser mirror for beam guidance, focusing optics, and the positioning system. The laser beam is focused onto the workpiece and can be moved relative to it. The laser beam machining is controlled by switching the laser on and off, changing the laser pulse energy and other laser parameter by the position either the workpiece or the laser focus. As earlier we have discussed that we have different materials, so we can do the machining on that material. For that we are using the different parameters. Suppose first one parameter is energy. Suppose your material is vary, so that energy will change. You can change the energy and you can do the machining. Suppose your depth of cut is very less, so the energy required for that is less. So you initially you have to do the study by the trial and error method in the different material. Basically those people are doing the research, so those are studying this parameter on the different material, and finally they will publish the model, mathematical model or empirical model. So using that model you can do the machining of the different material. So a laser is emitted from the source, is passed through the energy attenuator. After it is passed through the beam homogeneer and homogene the beam. So you can see here we are starting from the laser to the workpiece, and it is transferred through the number of system. The target illuminator and the machine vision control the beam to the focusing lens. The lens is moved by the precision motion stages The beam is then fall on the workpiece and then machining task place. So actually this is the control system you can see, and that is used to remove the material. Basically two types of laser micro machining method is used. First is direct writing and second is the mass projection. So here we have different system, and that system is basically based on the laser transfer from the origin to the workpiece. You can see here we have a laser and here we have a scanning mirror, and the laser is transferred to the mirror and that is transferred to the flat field lenses. Yes, you can see flat field lenses. So this is a direct writing method, and here we have a sample and scan field. So you can see that we have this direct writing system, though we are not diverging laser in a number of way. Second, you can see this is a mass projection system, and in mass projection system, as we have discussed, that we are first we are creating the pattern mask, and that pattern mask is used to do the machining. This is a first step. First step is you have to prepare the mask of whatever design is required on the workpiece. Here you can see there is a from the top. Here we have beam shaping and condenser lens here, homogeneous. Then it is transferred to the field lens, and on the field lens at the bottom we have mask. So that laser will transfer through the mask, and rest of the thing is actually obstacle for the laser. The laser will not transfer from the whole part. So that will be focused on the projection lenses, and you can see in the sample we have a exact shape of the mask. There is a mirror image basically. So even you can see in figure which is represented as a microstructure. So you can study this exact shape and size of the workpiece with the help of the microscope. So this, as we have discussed, this is a micro machining laser. So it required some magnifying system. Okay, and then we will continue in next lecture.